Last but not least, we're going to talk about acceleration. Acceleration is a change in velocity over time. So when something speeds up, it has a positive acceleration, and when something slows down, it has a negative acceleration. That's why in your car, the gas pedal is called the accelerator. When you step on it, you speed up, and so you have a positive acceleration. Since velocity is measured in distance per unit time, a change in velocity is measured in distance per unit time per unit time. So an example is meters per second or miles per hour per minute. Acceleration, like velocity, is a vector value. So remember, a change in velocity can be either a change in speed or a change in direction. So anytime an object changes direction, its velocity changes and it is accelerating. To calculate acceleration, we say acceleration equals a change in velocity over time. The change in velocity is the final velocity, labeled vf, minus the initial velocity, vi. And the equation is a equals vf minus vi divided by t. Now it's important to keep your vf and your vi straight, because if you are speeding up, your vf will be larger than your vi and a will be a positive value. If you're slowing down, your vf will be smaller than your vi and you'll have a negative value. So it's okay to get a negative value for your acceleration. It just means that whatever the object is, it's slowing down. Graphing acceleration is a lot like graphing velocity, but here our x-axis is still time, but the y-axis is velocity. So on a velocity versus time graph, the slope of the line is the acceleration. So a positive acceleration has an upward slope, like this. Whereas a negative acceleration will have a downward slope. And when an object is moving at a constant speed, the acceleration will be zero, and it has a straight horizontal line like this. That doesn't mean that the object isn't moving, it just means that velocity isn't changing. So here are some examples of a velocity versus time graph. If we have a straight upward slope like this, then we have constant acceleration. Similarly, a constant acceleration from time equals 0 to time equals 4, then from time equals 4 to time equals 7, we have a flat line, so velocity is constant and acceleration isn't changing. And then from time equals 7 to time equals 10, we have a constant downward slope, or a deceleration. And what we've been working to with our motion, speed, and acceleration is to get to Newton's second law of motion. I'm sure some of you have seen or heard this equation before, F equals ma. So that means force equals mass times acceleration. Now, this equation is responsible for everything from rocket launches to the swing of a baseball bat, as you can see in these pictures. And we're going to spend a lot of time going over this. So all of these videos will be posted on your homework hotline for you to come back and reference whenever you need them. You can use them to study when we get towards the summative assessment on this. And if you have any questions, bring them to class with you. And I hope you're ready to learn.